So the next presentation will be Rock Storm, talking about ecotremology, new insights into hidden ecosystems, a pioneer studies in meadow habitats. So I don't know if Storm, you are with us?
Yeah, I'm here.
Here we go. Here we go. So
cool. So now you can see my presentation.
Yes.
And you can hear me. Okay, perfect. Yeah, my name is Rok. I'm coming from Slovenia, and I would like to. I'm very glad that I'm here today with all of you, and I'm here today that I would like to extend the eco acoustic a bit more. I think I'm already the fourth person who will talk about vibration. Today, Rachele already mentioned vibrations, and Gianni in the first plenary talk also at the end mentioned the vibrational communication, and Valerio Mazzoni 2 days ago, or yesterday mentioned them. So yeah, first part of the talk will be kind of theory, why we think that ecotremology is something that is worth to research, to discover. And the second part will be how I will show you our results to maybe encourage you. So again, the paper and the biotremology that was established in 2016 by Hill and Wessel, and they did a distinguish between bioacoustic and biotremology. And why this is needed? We think it's needed because a huge amount of animals and beings around us is using vibrational communication to communicate. Here we can see a chart where more than 70% of insects in the world use this way of communication, so using the substrate-borne vibration, while just 1% is using the acoustic communication. So it's very common in insects. We can say even it's very common in arthropods. But of course, and if we look at this picture where the size of an animal represents the number of described species, we see that this black beetle representing the insects, and this red mite or tick presenting the other arthropods. They are presenting not majority, but like a large proportion of species described. And here is one bird and one elephant presenting the birds and the mammals. Vibrational communication is not just a thing of arthropods. It's also present in more visible animals that we can easily observe, like elephants and red-eyed tree frogs that we know, and rodents and golden moles and others. And just a few years ago, it was also described in birds. So yeah, the next paper that start my thoughts to work was the paper from Jerome and Almo from 2015, where they established ecoacoustic. And if we look now the table, we have the definition of bioacoustic, biotremology, ecoacoustic, and of course the missing one is the ecotremology. And I suggest that this could be a study of vibrations to investigate biodiversity and other ecological questions. Just to emphasize how important this is, it's like if we want to eavesdrop on ecosystem in my opinion, we need to record also the vibrations there, because as I mentioned before, so many animals, so many beings is using this communication channel that cannot be perceived by humans, because we simply don't have the receptors to perceive it, but majority of animals do it, have the receptors and use it as a way to communicate. So without recording vibrations, we are missing a crucial portion of the available information out there in our surroundings. So we already did the first step, and we defined vibroscape. We already heard today about vibroscape, and I think and about soundscape, and there was a word that soundscape is from the perspective of humans, from the perspective of man, while for the vibroscape we can say it's not from the perspective of man because we can't sense it. But in parallel to the definition of soundscape by Pianowski in 2011, we defined vibroscape as the vibration present in the environment, and we divided to three categories: biological vibration, geophysical vibrations, and anthropogenic vibration. This was published in the chapter of Biotremology in 2019. In further slides, you will see results, and they will be mainly considering the biological vibrations, and these consists of vibrational signals of species that use vibrational signaling, incidental vibrations that are produced by animals' movements, feeding, or other activities. Then we have vibrational component of airborne sound. I will show you that we can record bird songs also with vibrometers, and the plant acoustic emission. So our study was done here in Europe, in temperate zone, in Slovenia, and we just choose a meadow habitat to run this study, because we said, okay, many insects living in the meadow, let's go there and see what's happening there from the point of vibroscape. Of course, at the end, the photo was not so romantic. We had to bring many lab equipment to the field. These are the laser vibrometers. This is the equipment that we use to record vibrational vibrations in the plant or wherever you want to record it. It's not so handy as microphone and all these mini micro devices that ecoacousticians can use it. It's pretty clumsy, and it needs a tripod, it needs a computer to record, and it needs someone to take care of them because they are so expensive that you just don't want to leave them in the nature. But the concept is very simple. You put a piece of reflective foil on a plant, so you have a better reflection of the laser beam. You point the laser beam to the reflective foil, and you start recording the sound, the vibration present wherever you are recording from. In our case, it was always from the plant. So yeah, we after recordings were done, the analyzers came, and they were long because we choose the previous mentioned bottom-up approach. So we listen to every recording, we manually annotate events. For this, we have to say that we didn't know what we are annotating, because there is no library to go and to check what signals we have. So we decide to use the term vibrational type. So these events were categorized to 56 different vibrational type, and here is just a presentation of them. So they are quite different, and yeah, we operate with two different things, and this was richness, that was a number of different vibrational types, and abundance, and this is total duration of vibrational type. We set some observations, and this was the seasonal change, daily changes of vibroscapes, short temporal coordination of vibrational units, and the spatial distribution. Let's first look at these seasonal changes. We avoid the winter because we just don't like low temperatures, so we just and this was the best proxy of the tropical forest, so we just record from spring to autumn. Here you can see the box plots, the upper one showing the biological vibrations, so these are including the acoustic, the vibrational part of acoustic signals, the activity vibrations from insects or other animals, and the signaling activity. And the lower box plots are showing just the vibrational signals, so just the one category of the biological component of vibroscape. We were recording from the beginning of May till beginning of October, when the activity drops almost to zero, so we said, okay, enough for this year. And the highest abundance, it's reached in the beginning of July, but biological vibrations were also high in the spring, but this was due to the vibrational component of acoustic signal. So here are three spectrograms just to show you. The spring one, it's the top one. Here you can see with yellow showing the vibrational component of birdsong, and with red it's marked one of the vibrational type. The summer, that is full of vibrational types, and the autumn, where there were fewer vibrational types and some events that we couldn't really connect to any vibrational signals. They were just there. So we each time we recorded on this meadow, we recorded for 3 hours. And then the 10 minutes interval was kind of sampling unit. And after this, we draw all these accumulation curves. And we saw that almost none reached the plateau, so we would expect to record more different vibrational type if we would record longer. Anyway, even if we undersample place, the NMDS analysis show us the difference between these seasons. In green we have spring, and then early and late summer, distinguishing between each other, and then the autumn period. So yeah, then we look also at the day-night changes. For this reason, we continuously recorded for 24 hours. But at the end, we figure out this is too much recording to manually annotate everything. So we decide to choose 6 different periods of the day, half an hour long, from sunrise to midnight in the middle of the night. Sunrise and sunset were set according to the astronomical calendar, and then all others were divided into half. And then when we looked at the abundance of the signals, we see that the abundance is always reached and in the afternoon period. If you remember the talk from Mazzoni yesterday, he said that they observed the drop of activity in the afternoon, and but in our case, the activity was highest in the afternoon and dropped also almost to zero at midnight and in the morning. And this was very correlated with the temperature. The correlation was 0.8, so very high. And probably, so we can assume that the temperature is kind of limiting the signaling activity during the night. Then we also look at the short temporal coordination of these signals. We choose the recording from beginning of July, when the activity, when the abundance was the highest. Here we have the presentation of 3-hour recordings of all 13 different vibrational types that appear there. But from this graph, we can't see much. So we went back to our raw data. Because we annotate everything manually, we draw a square or rectangle around each signal. And so we had data for each signal, the minimum and the maximum frequency, so the frequency range, and the end, and the beginning and the end time. So from this data, we calculate the overlap, and 2 different overlaps. The overlap in time and frequency, shown here with white square, and the overlap just in time, shown with the purple line. So, and then we observe the overlap on our recordings, but we get a number, but we had nothing to compare to. So we said, okay, we have 3-hour recordings and a certain amount of vibrational types. Let's distribute these events randomly through this 3-hour recording. And to gain the statistical power, we just repeat this 1,000 times. And when we did this, we see that our observed overlap on the recordings from the meadow had much, much smaller and statistically significant lower value than the overlap if we calculate from the randomly distributed vibrational events on the same recording. So this is kind of showing that animals in the meadow that use the vibrational communication channel are dividing it in time. We then we take the whole early summer period, because this period consists of recordings with lower abundance and higher abundance, and here we can see that in the recordings with lower abundance, this effect was not observed here in the beginning of June and end of July, but all in the middle we could have observed this. Just the last spatial experiment that we did, we choose 3 locations on the same meadow. On each location, we choose 2 different species of plants. One was Gallium molugo and the other Carex hirta, 2 different species from different plant family with different plant geometry. And when we build community matrices, we run the NMDS, and we can see that the vibroscape from one plant species cluster together, and that the community from the other plant species cluster also together. And you can't get these clusters if you look at location on the meadow. So yeah, just to sum up, for seasonal changes, we see that there is a big difference during the season. For day-night changes, we observed a big fluctuation. We showed that the community of animals using vibrational communication channel is dividing this channel in time. And we see that the different plant species on the same meadow can have different vibroscapes at the same time. So this is it from me. If there are any questions.
Thank you, Roxtam. And let's wait for some questions. We go through the chat to see if there's any. I see Almo Farina has probably a question.
Yes, I have just I can see. Okay, thank you. I can see myself, but
we can see you, Almo.
Okay, I can see. Yes, thank you. Just a consideration. The vibroscape is operating in this case at a scale, spatial scale, really different than the scale of a soundscape. What do you think about to connect these two worlds? Because otherwise it's not so easy, no? So it's just a comment.
Yeah.
I have no idea how to do, but you are working at micro scale, and we are working at a scale that is 10 times larger or more when we are using our soundscape.
Yes, this is one of the biggest differences between those two systems, because sounds can sounds can propagate through like many or through entire habitat. But in case of vibroscape, we are talking about distances of maybe few centimeters, few decimeters, maybe meters. We except if we go to elephants, they are communicating in the range of kilometers. But if we are staying in the world of insects, yes. But anyway, insects are so much smaller than we are, that if we compare these distances to their scale, I think this could be still we can still compare these two things. Of course, if we put ourselves in the role of emitter or receiver in this case, but yeah, from the perspective of scales, these are two totally different worlds, and because we can record as vibration. As vibrations, also the audio events, so the bird songs, for instance. This can make vibroscapes in different places more similar, because we can record the same bird in two totally different points of meadow, but we can't record, for instance, one insect on two totally different points of a meadow.
Okay, thank you.
Yes. So, thank you. I think it's time to wrap up and to